time you're ready.
All right, thank you. All right, I just want to thank everyone again for joining us. So today I'm going to talk about integrating local mine grids with real-world coordinates and field verification. This one's to switch. The presentation summarizes the results of the data compilation, integration, and verification of the historic data for the Coliseum project that was used to compile a comprehensive database. This work enabled a current drilling program, resource estimate, and an independent technical report that meets historic 2012 standards of disclosure. The work completed includes a site visit, data gathering, which included taking samples for independent verification, data and database compilation, review, and reporting. The image you see is of Coliseum Mine when it was active in 1987. In March of 2021, an Australian publicly listed company entered into an agreement with Barrick Gold Corporation to acquire the Coliseum Gold Mine, a past-producing precious metal property located in San Bernardino County, California. In January 2022, Geographics was engaged to produce a mineral resource estimate and technical report on the Coliseum project based on the historic data. Gold mineralization at the Coliseum mine, located in the Clark Mountain Mining District, was discovered in 1865, but no recorded production occurred until the 1930s. Since the early 1970s, numerous companies have held the property. The Coliseum mine was active from 1987 through 1992, producing over 340,000 ounces of gold. 122 boxes of data were received for the Coliseum project. Due to the amount of data, the need to convert files to a digital format so they can be indexed, searched, and shared in a secure environment with staff worldwide. The company elected to upload the data to a cloud-based document management system. Geographics compiled a verified digital project database of all obtained land status, geology, surface topography, drill hole, assay, and lithology data used in the resource evaluation for the Coliseum project. As of February 22nd of 2022, 6,105 documents and 3,289 maps have been scanned and indexed into the document management system. Approximately 50% of the documents have been indexed, with a primary focus on documents that would aid in the evaluation of the historic and remaining resource. While the data obtained to date is extensive, the data found to date is incomplete and can only be used as it exists. Data compilation is still ongoing. Several digital surface topographic maps were created between 1980 and 1993 from aerial imagery. Raster to vector software was used to convert the paper maps to digital format and create digital elevation models as shown above. The focus of this slide is the 1984 surface topography. The aerial survey used to create the 1984 surface topography was flown by the McLean Aerial Mapping out of Tucson, Arizona in 1983 prior to mining. The source for the digital topography for the Coliseum mine area was the mine planning map at a scale of 1 inch equals 100 feet with 5-foot contour lines created in August of 1984 in the 1927 California State Plane Coordinate Zone 5 system grid. The contour lines from this map were digitized using a raster to vector conversion program. Elevations were assigned by this program. The results were overlaid to the original map and checked for errors. A surface grid was created from the topo language. The final topography was flown in 1992 before the mine shut down. The 1992 survey was used as a ground surface for the resource estimate. The aerial survey used to create the 1992 surface topography was flown by Cooper Aerial out of Las Vegas, Nevada on January 2nd of 1992. The source of the digital topography for the Coliseum mine area report was the survey directly over the pit and mine workings at a scale of 1 inch equals 100 feet with 5-foot contour intervals. The grid was the Bond local mine grid. Survey control points were found for the vertical elevations and agreed with the generated topography. The contour lines from this map were digitized using a raster to vector conversion program. Elevations were assigned by the program. The results were overlaid on the original maps and checked for errors. The surface topography was converted into a 3D digital terrain models representing the surface topography as of January 1992. Drill hole project databases. The extracted 1972 through 1991 drill holes with assay samples and lithology within the project area were imported into a MapInfo/Discover database. Collar coordinates for historic drill holes were surveyed in their respective local mine grid coordinate system in use at the time of the survey. A total of 599 drill holes were entered into the collar table within the Coliseum mine area to be used in the resource estimate. Drill holes for exploration targets were not included in the database. There were a total of 37,147 assays in the historic database. The data for historic holes were available as scanned copies of paper files in PDF file format. The data for assays ranges from scans of original assay certificates and submittal forms to scanned printouts from early digital assay databases through 1985. The computer printout files were processed using an OCR text recognition system. The results compared against the originals and any errors were corrected. Those results were then checked against the assay certificates and any discrepancies were corrected. Subsequent assays were scanned from assay certificates and verified. Historic rock codes were entered for each assay interval. Rock codes were not available for all assay intervals. There were a total of 3,206 lithology values entered into the database. In this example, the historic lithology log of drill hole CP5 created in 1974 is shown on the left. The converted lithology database for hole CP5 is shown on the right. Mine grid coordinate systems are often dependent on the equipment available to survey points. For surveying, total station technology replaced the theodolite in the 1970s as the survey equipment of choice. In the United States, GPS technology was first developed for military use starting in the 1970s and became fully operational in 1993. Historically, plane table alidades were often used to map small areas, and starting in the early 2000s, handheld GPS units are regularly used by geologists to collect field data. Even though their accuracy has increased from 15 meters or 49 feet for the Garmin 12CX units to 3 to 5 meters common for today's units. They are by no means considered survey grade inaccuracy. The source and accuracy of survey points needs to be taken into account when converting a local mine grid to real-world coordinates. The total station was introduced in 1971, and for the first time, distance and angle measurements could be recorded by one instrument. The total station is a transit integrated with an electronic distance meter, which can read slope distances from the instrument to a particular point in land. Most mine planning packages available during the 70s did not have the ability to work in geographic coordinate systems, instead relying on XY coordinates. The Sharp local mine grid based their grid on the 1927 California State Plain Zone 5. Notes from a 1980 survey did not define the 00 point. The Sharp local mine grid elevations were obtained by subtracting 57.2 feet from the state plain elevations. The Draco local mine grid modified the California State Plain system by dropping the first two values in the easting and one value in the northing to conform with current limitations for computer processing. The Amselco Bond local mine grid was rotated north 45 degrees west to allow compilation of geologic cross sections at right angles to overall the trend of the mineralization. Table shows 4 different drill holes in their respective coordinate systems. And here's an example of the Sharp local mine grid. It shows the geology and the current hole locations. This map is the Draco local mine grid. It shows the regional geology with rock sample locations, claim outlines, and a surface topography. In the 70s through the 90s, computer limitations for fixed format numeric fields was constrained by software, so coordinate systems needed to be modified to accommodate this limitation. Also, most mine planning packages available during this time did not have the ability to work in a geographic coordinate system, instead relying on XY coordinates. In this example from the Coliseum project, the Draco local mine grid modified the California state plane system by dropping the first two values in the easting and one value in the northing to conform with historic limitations. The table compares digitized drill holes from a map with the California state plane coordinate system to the color coordinates from the Draco local mine grid. As you could see, the locations match fairly closely. This map from the Coliseum project shows the geology of the deposit and the current drilling. The map shows the state plane coordinates grid at a 45-degree diagonal and the local mine grid running north-south and east-west. This map was used to convert the e0c98efd/Bond local mine grid maps to the California state plane real-world coordinate system. Note that in this example, the local mine grid is rotated 45 degrees from north to parallel the mineralization. The two prior mine grids for this project were aligned with north-south. Traditionally, many people use a simple non-Earth meters or feet coordinate system to display local mine gridded data or data from a sampling grid in a project area. While this allows the data to be displayed spatially, it cannot be integrated with other projection systems. In the Coliseum dataset, one of the maps contained both the California state plane grid and the e0c98efd local mine grid, as well as the drill hole locations. This example from the map shown previously shows a map with the state plane coordinate grids in gray and the local mine grid in red. It is rotated to conform to real-world coordinate space. Map Info / the Discover platform was able to create an algorithm that allowed the e0c98efd local mine grid to be integrated with real-world coordinate system. Working copies of color coordinates, downhole survey information, assays, and lithology were converted for data verification. Verified data was loaded into a project-specific Microsoft Access database. The database includes data from 604 holes for a total of 186,017 feet or 56,698 meters. There were a total of 37,147 assays in the historic database that were entered in from the historic data. The data verification process for drill holes involved the following steps: comparing collar data to survey, assay, and geology data for incorrect depths, azimuths, and dip values. Check survey, assay, and geology data for length overruns, survey grid depth greater than total depth, and overlapping intervals. Randomly checking drill hole geologic survey and assay data against logs and hard copy data. Plot sections and check for obvious errors in hole trace orientations and potential missing data. This is a 3D model of the mine site created from the 1992 surface topography as well as from the historic drill holes. I conducted a field examination of the project area on April 4th, 2022. The visit included a field review of the current drilling location, confirmation of the location of a number of the historic drill holes. The historic Coliseum drill hole database was queried for collars within 5 feet of the 1992 surface topography. Those drill hole locations were imported into a Garmin Montana 750i DGPS, and the points were checked against drill hole locations found on the ground using the Montana with an accuracy of 8 to 10 feet or 2.4 to 3 meters. The holes were also imported into the Android tablet for use with Discover Mobile. We have found the larger screen makes location in the field much easier. Drill holes in the vicinity of the Coliseum mine pit areas were difficult to locate due to degradation by subsequent mining activity, post-mining reclamation, and other ground disturbance. We were able to locate 4 of the holes, all within 6 to 7 feet of the historic location as measured with the Montana. And the hole C8814, I want to take your attention to there because it is going to be the drill hole located in the next slide. So the hole on the left, that's the C8814 from the map prior. And the picture on the right shows the process of metal detecting to locate historic drill holes. The historic data compilation allowed the company to complete a resource estimate, define a 2022 drilling program, and an independent technical report meeting JORC 2012 standards of disclosure. A mineral resource estimate of 813,000 contained ounces of gold was defined. Gold is currently trading at $2,000 an ounce. So approximately 1.6 billion of gold in the ground. The assay composites from core hole C2204 and C2205 from the 2022 drilling program were used to confirm the estimated grade of the block model calculated from the historic drilling. The image shows the 2022 drilling. A JORC report is a technical document that provided detailed information about the mineral resource and or ore reserves of a mining project. It is prepared in accordance with the guidelines set out by the Joint Ore Reserves Committee, which is internationally recognized the standard of a mineral resource. 2023 drilling is currently underway. And that is the end of the project, and I will take any questions.